All right, welcome back to Principles of Electronics, lesson number 2. Today, we are going to talk about three very important characteristics in the world of electronics: voltage, current, and resistance. My goal here today is to just build a diagram, a circuit diagram, not a schematic. Schematic's different, but we're going to build a diagram, and we're going to show how current flows, what voltage is, and what resistance is. And then I want to relate that to something as simple as a water tower with a hose coming out of it and make comparisons. Sometimes people see the water tower and the flow of water and so forth, and it's easier for them to understand what's actually happening in the diagram. So that's what we want to accomplish today. So let's start by creating our diagram. I currently just have a battery. Our battery has potential. Potential is really what voltage is. So, for instance, this diagram, this really poorly looking diagram, is a 9-volt battery. We're going to use a 9-volt battery for our potential, for our voltage. And before I do that, let me define a few things here. Usually when we talk about voltage, we refer to it as volt, and the symbol is a V. Current we refer to as an amp, and the symbol is I. The official term is ampere, but amp for short. And resistance, it's ohm, and it's represented by the omega symbol. Funny looking horseshoe. All right, so when we talk about resistance, it's ohm. When we talk about current, it's amp. When we talk about voltage, it's a volt. So those are pretty easy to remember. All right, so let's build our diagram. So let's say we have a battery, and we'll just say we have a light down here. I'm just gonna put L in there for light. And we want to light that light with this battery. So if we take, and this is going to be the simplest form. This isn't going to be anything in depth whatsoever. It's just going to be its simplest form. So our battery has always a positive and a negative terminal. They're always marked on the batteries. So in order to get that light to turn on, we have to take a wire and we have to attach the negative terminal to the light and then come back out of the light and go to the positive terminal. Once we do this and we connect this battery to this light, what we're doing is we're taking the voltage or the potential of this battery. It's forcing current through the wire in the form of electrons, and those electrons travel from the negative to the positive in this way. And by doing that, by that current going through this light, we're able to light the light, and it goes on. So our voltage is the potential of the battery, pushes the current, or the electrons, through the wire. They go through the light. That comes on, turns on. But you always have to have a path back to positive. Now, we're not going to get into this now, but wires do have resistance, minimal, but they do have resistance. Sometimes we have to add resistance in these wires ourselves so we don't burn a light out or so forth. But I'm going to go to the extremes. I'm going to say that the resistance here is extremely low simply because we have no resistance, except minimally in the wires. But what if we decided, or not decided, but what if we just took a pair of pliers and, accidentally opened up that wire right there? If we did that, that would stop completely our flow of electrons from the negative to the positive. Well, if those electrons can't flow, then that light then would have to be off, or it would turn off. That would be a very high resistance. High resistance being it's so high, it's air, there's nothing there for the current to travel through. It's so high that resistance can no longer flow. All right, that's our example there. Now, if we wanted to, we could close this again and that light would come back on. And that would be great. Now, how does this relate to our water tower? And some of you may be looking at this going, yeah, I don't have a clue what you're talking about. What if we filled this with water and called that our voltage, our potential, however much water we have in here? And then let's say we have a little valve right here. So it's not allowing the water to flow. Well, if it's not allowing the water to flow, that means we have a very high resistance because water's not flowing. But if we open that valve and we let that water flow down through this hose, that then is our current. So our potential, or our voltage, is forcing the water down through the tube. If we close the valve, we create resistance. If we open the valve, we have minimal resistance and the current can flow freely to wherever we want it. If we're watering our lawn or if we're squirting somebody, whatever. So that is how we can, I hope that this picture here maybe is a little bit easier to see and you can relate it to the diagram over here. Once again, I want to make sure that this is a diagram. This is not a schematic. We're just doing it as a diagram for representation. All right, so let's review real quick. We have voltage, we have current, and we have resistance in any circuit. In our diagram, we can show that the electrons that form the current travel from the negative through the light to the positive, and by doing so, it lights the light. If we open that circuit up, it's called an open circuit. If we open it up, the light goes off because no current can flow. If we relate it to our water tower example, we fill our tower with water. We put a valve here. That's very high resistance. Current cannot flow through that tube. But if we take that valve or we open that valve up completely, water is allowed to flow down through and our resistance is very small and allowing the water to go through. All right, that's it for today on voltage, current, and resistance. If you have any questions, please leave them in the comments. And as always, please subscribe to Sprider Web Education.